Hello and welcome to another video in this PyTorch and neural network series. Today we will be getting into how neural networks work, but before we get into how neural networks work, I want to tell you guys that these topics will be daunting and confusing at first, but once we start coding in the next few videos, it will all start to make a lot more sense, so just stick with it. So a neural network is a machine learning model that is inspired by the structure of the human brain. It is a collection of interconnected nodes or neurons that work together to perform a specific task. That's a very high level explanation, but we'll get into it more in depth soon. For now, you just need to know that the picture that you see on the screen is an illustration of how the mathematical operations in a neural network are linked. We will be building the neural network from scratch over the next few videos, but now I will continue with this high level explanation. So a neural network takes in input data. So a neural network takes in input data, processes it through these hidden layers, these series of hidden layers over here, and produces an output, which is this pink layer, pink node over here. The hidden layers are made up of neurons. This is how a neuron looks like. So this diagram over here would be one node, and this output would be all these arrows over here. As you can see, each layer bolts on from the output of the previous layer. And the layer is basically just a series of neurons that are aligned together. So each layer builds on the outputs learned from the previous layer, allowing the network to learn more complex representations and patterns of the input data and map them to a desired output. The building block of a neural network is a neuron. The neuron takes in data and produces a single output. As you can show here, the single output. The inputs are then multiplied by weights, and then summed together to get the neuron out. This operation we can actually represent as a matrix multiplication. Some people like to refer to it as like a dot product between the weights and the inputs. But after we get the output, we can use this output as the output of the entire network, or we can just feed it to the next level. I'm sure you've heard of training a neural network, but I'll explain what training basically is. When you train a neural network, we're going to take the input layer, we're going to feed the data in the input layer and do a forward pass. Basically just all the forward calculations, just going to do the matrix multiplication for this node and all the nodes, and we're just going to get the output by just doing them all sequentially, all those operations. The output is then fed to a loss function that you have set. The loss function is basically just a mathematical operation, by the way. You can see different examples of them. So this is the MSE loss, which is just we take the output and the desired output, we minus them and square the difference. Or square that difference. And the cross entropy is a bit more complicated, where we take the sum of the product of the true probability times the log probability of the model's prediction. But we'll get into cross entropy in the next video and dive more into depth there. Go over what actually happens after we've given it to the loss. So after it's given to the loss, the loss determines how good our network has performed compared to our desired output. We then take this loss and we backpropagate by calculating gradients for the weights and how the weights change the output. And we use those gradients to then change the weight so that the output or the loss function is minimized. That's all you need to know so far. We will build on this in future videos and also solidify your understanding in the process. I hope you guys enjoyed this video and it helped. Please leave a like and subscribe. Till next time. Bye.